Hello world, my name is Scott Clare and I'm coming to you from California. The ceramic sculpture behind me, I named the worship because of how its crystal-like forms reach for the sun. The worship is 5 feet 4 inches tall and weighs an estimated 130 pounds. Here is a photo of how the worship appeared in my 1978 Masters exhibition, when it had the brown color of a reduction firing. At that time, besides feeling dubious about glazing, I feared submitting my sculptures to 2 firings. So, each of my ceramic sculptures were fired in a single cone 10 firing. I graduated, but I was never satisfied with the unglazed look. So maybe 10 years ago, I began to reason to myself that stoneware is a lot like rocks, and maybe, just like granite countertops, they could be polished to a smooth, shiny finish. In the first part of this video, I will show you how I polished the worship to the glaze-like finish that you see on it now. In the second part, I will tell you how I made large stoneware hand builds without devastating cracks. Okay, here we go. Before I started the project of polishing my sculptures, I went to a local granite polisher and asked him to try it on this unglazed part of this pot. Here. This is what he got. He got a smooth, glossy-like finish. So I'm going to show you what happens. I'm going to go through 4 stages of polishing it here, and you will see that this very, very rough unglazed part of this pot will become polished and shiny. Here's a close-up of it right now. Very rough. Okay. I'm going to secure it in place because the polisher could grab it and throw it. Okay, so this will be stage 1, 50 grit polishing pad. So now I will go to stage 2, which is an approximately 100 grit pad. Okay, so a little smoother. And this last pad that I'll use is a 1500 grit. Okay, so I started with this rather rough, gritty surface, and after polishing I achieved a smooth, shiny surface. And interesting is that I get a very different colors and texture in polishing this pot versus my kind of homogeneous buff-like color that I'm achieving with the sculptures. And as you might expect, polish out different clay bodies, you're going to get different effects of color and texture. Before I leap fully into this project, I tied the worship here to this fence and experimented with the effects of polishing. At the time this photo was taken, you can see the upper crystal is nearly clean of the outer crust. The one right below it is in progress. It's here that I became frustrated that polishing with the 100 grit number 1 pad was way too tedious. Once I became encouraged that the 50 grit pad was going to make it easier to remove the outer crust of the reduction firing, we laid the sculpture down on its side where it was easier to access the lower parts and the undersides. Here we have the sculpture down on the side with the most erect part of the sculpture down in the ditch. The slab that I've been working on right here is 36.5 by 7.5 inches. I'm using a 50 grit pad, polishing pad, to remove the outer crust. The outer crust looked like this right here. You can see the brown of it, and when removed it goes to this buff color. The goal is to get it to a homogeneous look like you see here, more homogeneous look. I still have some marks that I may or may not grind out later. So I have finished removing the crust, and the sculpture's now in its upright position, mounted on its concrete base down here. I'm in my fourth stage of polishing, and this is a 600 grit polishing pad that attaches to the electric polisher by Velcro. Two granite fabricators told me that polishing with water is the best way to polish. I didn't do that when I was removing the outer crust, but I am now polishing with water, and whatever else water does for the polishing, it does keep the dust down and kind of tells you where you've already polished as you're working. In a previous clip, you saw that I turned off the electric polisher to polish by hand those spaces that the electric polisher could not reach. To reach those tight spaces by hand, you've got to cut the polishing pads. Polishing pads have teeth on one side and Velcro cloth on the other. When the teeth line up straight, it's easy to use the utility knife and cut right through the Velcro cloth on the other side. When they don't line up perfectly, you may have to score a little bit and follow up with a hammer and chisel. For those tight spaces that you can't reach by hand, you can glue the polishing pads to painter sticks. The flexible one is thin and can reach into the tightest of spaces. The thicker stick, you can apply more pressure when you're polishing. For polishing my sculptures, I use the 50 grit pad first, followed by 5 succeeding grit values, and then ending with the 3000 grit pad. For polishing the pot, you saw that I started with the 50 grit pad, and then followed with the 1, 2, 3 pads. The number 3 pad being approximately 1500 grit. I remain unsure whether or not there is any noticeable difference between the finish I got for my sculptures versus the finish I got for the pot. In both cases, I achieved a surface that is very much like a good glaze job. And for the sculptures, I got a finish that was more suitable for the crystal-like forms. Polishing like this can be tedious, but it's just one more thing that you might consider, and it could save you
the frustration and disappointment that often comes with glazing. My graduate committee required that I submit scale models of my sculptures before building them. It was about 44 years ago that I submitted the scale model for the worship and explained to them my plan that I would build it to the maximum height allowable for CSU Fresno's largest kiln. The chairperson of the ceramics department told me that I could not build it that large and fire it to cone 10 without significant cracking. In the next part of this video, I'll show you how I did it. Explaining how I successfully built and fired the worship without cracks requires that I first present some practical aspects of shrinking clay. The challenge with clay is that cracking is a normal part of the shrinking process. Consider how clay dries in nature. It breaks into smaller, fragmented sections. Suppose you use a clay that shrinks 5% in the drying stage, and you roll out a slab that is 20 inches long and 5 inches wide, and you allow it to dry. That 5-inch width would shrink an insignificant 1/4 inch, but the 20-inch length would shrink 1 inch. That is, the length of your slab would have to shrink and move 4 times as much as the width. Because the width barely moves, to facilitate the shrinking, your clay slab will break up the longer dimension. Then, like in nature, the smaller fragmented sections would move toward their respective centers. Now, of course, fragmented sections of clay in nature are not congruous, and your slab is not going to break into equal pieces. Let's look at this porcelain slab, which is 20 inches long and 12 inches wide. To illustrate how it will shrink, I drew black arrows butted up to each corner. Here's the slab after 4 hours of drying. No noticeable shrinking. At 20 hours of drying, notice how the corners have moved away from the black arrows and toward the center. Compared to the example of the gray slab, where the length shrank 4 times as much as the width. The proportions of this porcelain slab suggest that the length will shrink less than 2 times as much as the width. Still, notice that the cracks have formed in a way that breaks up the length more so than the width. At 24 hours of drying, each corner has moved closer to center. And as those broken sections individually move toward their respective centers, the cracks become wider. At 28 hours, the slab is nearly dry. The lower left corner has moved about 3/4 of an inch, and the other corners about 1/2 inch each. Pretty consistent movement toward center. Now I want to convince you that there are things you can do to control cracking. Consider these 2 slabs, 21 inches long and 6 inches wide. A cloth canvas was laid over a plastic table, and the slabs were rolled out and cut to size. Red rectangles, 6 inches long, are laid on each slab to reveal any change in the width. Yellow dashed lines indicate the starting points of the outer edges of the slabs. The green tape shows the starting points for the inner edges of the slab. Now, based on what I have showed you so far, you might expect that the slabs that are nearly 4 times as long as they are wide will do two things. Number one, they will crack in a way that breaks up the length. And number two, for all the shrinking movement to be inward toward their respective centers. As you will see, neither of these two things happened with these slabs. After 17 hours of drying, there is no noticeable movement. After 36 hours of drying, you see the left edge of slab A has moved about 1 inch. However, the right edge of slab A has moved just slightly away from the green tape. For slab B, the changes are similar. So why no cracks? Why no movement away from the green tape? Did you notice the wrinkles in the cloth? Look again at the 17-hour photo and at the 36 hours. As expected, both slabs have shrunk about 1 inch in length. But instead of shrinking inwardly toward their centers, they've moved the only way that they could, toward each other. The weight of slab B kept slab A from moving away from the green tape, and the weight of slab A anchored slab B in the same way. At 52 hours, the slabs are almost completely dry, with each outer edge moving a little more than 1 inch. Each inner edge has moved less than 1/8 of an inch away from the green tape. When the red rectangles are moved even with the lower edge of each slab, they show that each width shrunk about 1/4 of an inch. Compared to the porcelain slab that was rolled out on plywood, these gray slabs were able to slide freely as they shrunk, and so they did not crack. You can choose how your clay handbelts will shrink. In an assignment to combine 2 or more thrown pieces in a hand-built project, I decided to try a nude. In this photoshopped photo, it shows how I began the project. I joined the 2 thrown pieces at the waist and then pushed and paddled to shape the body. I added thrown breasts, hair was done with extruded coils, and as I recall, when I was done, the piece was 22 inches long. Notice, though, that the hair and hip create anchors that will inhibit free and consistent shrinking towards center. The gravity to hold the hair and hip in place are in conflict with the clay needing to shrink. If this sculpture were left to dry in this position, it would surely crack at the waist. So I built a support that allowed me to lift the sculpture into the vertical position when I was not working on it. It dried in this position without cracks. Gravity can stress joints, but it can also force them together. I asked that this nude be fired in this standing position by leaning it against a kiln wall. Because of the need to fit the projects of many students into the kiln, it was fired prone. It cracked at the waist. Now, to explain how I successfully built the worship and fired it to cone 10, you find me recording in the ceramics corner of my garage. First, a little about hand building. For scoring, a needle is way too tedious, especially if you are working big. A hair pick with 1/2 of the metal tines removed has a nice handle and scores quickly. After scoring, rather than water, I apply slip of the same clay with a brush. When you score the clay, you are opening up the outer drier surfaces to get to the wetter and softer inside of your slabs or coils. Wetter parts are more conducive to sticking together. The wetter your slabs or coils, the more likely that you will have strong seams. For the lower half of the worship, the slabs are rolled out 1 inch thick. As I built higher, I used thinner slabs. I did the normal pushing, tooling, and paddling of slabs together, but when possible, I also reinforced the seams with a coil. While the worship was on its side, I took this photo from an opening at the base. It shows my tooling work inside the sculpture. For the slabs you see at the top, right, and bottom in the photo, you can see the tooling of coils that reinforce the seams. The slab at the left, with little tooling, closed the form and made reinforcing with coils impossible. That last slab was tooled as much as possible from the outside. In the photo, you also see the support slabs that extend across the space. I remain unsure whether the supports were a contributing factor to the successful firing of the worship, but at the time, it seemed like a good idea. Early I suggested that when hand building, you should work as wet as possible. That means working with flimsy slabs that need support. Here is a Photoshop drawing of a wood support that I used for building the worship. Notice the booster that is slid underneath the bottom of the wood support. After another crystal is formed underneath, the wood support is no longer needed. The booster allows you to safely lower, then remove the support away from the sculpture. Next, another wood support for another large crystal. And once a supporting clay structure is formed underneath, the wood support is removed. Each of these large crystals that reach for the sky are at an angle of 50 degrees or larger. Using an angle this steep allowed for the shrinking of those forms to move downhill toward the seams. Gravity can stress seams, but can also push them together. Here's the rest of the sequence for building the worship. If you are working on a large hand built over a long period of time, you can use a spray bottle and plastic covering to keep it moist. And be sure to use plastic wrap to help it dry slowly and evenly. If you are planning to fire and then polish your piece, to make the early stages of polishing go easier, after your piece is dry, you might consider smoothing it with 200 grit sandpaper. The worship was built on a custom-made cart, and it stayed on that cart until it was time to transfer it to the kiln. I guesstimate that it weighed about 140 pounds. That kind of weight creates a lot of drag on a base that would eventually sit on a kiln shelf or fire brick. The possibility of cracking while the base tried to shrink toward its center was a serious concern. To allow the base to move freely, I extruded 3/4 inch coils to make rollers. I cut the rollers into 1 1/4 inch pieces, bisfired them to cone 06, and set them aside until the worship was ready to fire. Here's the shape of the base of the worship. Before firing, the longest dimension was 19 inches. The longest opposing dimension was 14.5 inches. If you think back to the porcelain slab example, you know that cracks will favor breaking up the longer 19-inch dimension. Kind of like this, I placed the rollers with respect to the longer dimension, placing each about 1 inch away from the outside edges of the base. I did not use marble-shaped rollers like you see in this diagram, but for some rollers, I think it might be a good idea. This Photoshop drawing depicts how it looked on the day the worship was fired. There are two critical temperatures in a cone 10 firing: boiling at 212 degrees and quartz inversion at 1063 degrees Fahrenheit. And I wanted to report here how the worship passed through each of these stages safely. The power of steam at 212 degrees can blow up pots. My firing record for the worship shows that I used just the pilot flame to slow dry the worship for 7 hours. When I started the burners, the top temperature was 300 and the bottom temperature 250. Quartz inversion is described as an especially quick expansion of the volume of quartz in ceramics ware. It occurs at around 163 degrees, as I stated earlier. Remembering that the chairperson of the CSUF ceramics department told me that the worship could not be fired to cone 10 without devastating cracking, it was quartz inversion that I most feared. During this period in the firing, it is important that heat is evenly distributed throughout the piece and so throughout the kiln. While heating, I adjusted the burners to take 8 hours to pass between the temperatures 980 and 1200 degrees. I also used cone 021. When the cone went down, the quartz inversion period had passed. I also monitored for the quartz inversion during cooling. It took 2 3/4 hours to cool from 1100 degrees down to 1050 degrees. And when I got there, I closed the dampers and it was done. Firing the worship to cone 10 took 3.5 days. Cooling the kiln past quartz inversion to 1000 degrees took another day. Holding a wry smile while watching the chairperson of the ceramics department do a circular inspection for cracks, that memory has lasted 43 years.
So this is another sculpture that I have held on to for 40 plus years, and like the worship, polished it to the finish that you see on it now. My hope for this video is that it gives a little bit back to the academic discipline that was so gratifying to me, and that it reaches and helps to give confidence to those who aspire to build stoneware ceramics big. Thanks for watching.